In this homework example, you're asked to identify different types of fraction models and represent different scenarios using fractions. So let's just look at different types of fractions that we learned in this unit. So first we have a quotient, basically a division problem such as fair sharing or grouping into the same size copies. So let's look at two examples of this. Tom has $3 and shares it with 12 friends. How much money does each friend have? Okay, so the fair sharing, he's sharing the $3 amongst 12 friends. So he's partitioning the $3 into 12 equal groups. So the fraction that represents this situation is 3/12. The next one, Sarah has 15 apples and uses 3 apples per pie. How many pies can she make? Well, in this situation, she has the part she's starting with 15 and she's grouping it to the same size copies. So she's dividing the 15 into groups of 3. So we could represent this by 15/3. And for now, we're not going to simplify these fractions. So 15/3 or 15 divided by 3 is 5. You may know this is 1/4, but we're going to do that later on in the unit. Now, another type of way we use fractions is a part-whole model. So typically, not always, but typically we use words like out of, and we're comparing a part to a whole. So let's look at an example. Afton liked 5 out of 6 movies he watched. What fraction of movies did he like? So here we're asking, of all the movies that he watched, which was 6, how many did he like? So the amount he liked has to be less than or equal to the total number he watched. So that's why it's a part-whole relationship. The part he liked was 5 out of the whole, which is 6. Okay. The next type is a part-to-part ratio. Typically, we use the word ratio when we're talking about part-to-part ratios. There are other types of ratios as well, but it typically comes up when we talk about comparing two parts. So compares two parts to each other. So here's an example similar to the last one. However, we're not comparing a part to a whole, we're comparing a part to another part. So Brandon liked 3 movies and disliked 2 movies. What is the ratio of movies he liked to movies he didn't like? So notice it said, what is the ratio of, you start with the movies he liked, to, and that's the word that separates the two components you're comparing, movies he didn't like. So unlike the last one, when we had a total of 6 movies, that was the whole. Here we're breaking the whole into pieces, sometimes 2 pieces, sometimes we could divide them into more. And it's 3 movies compared to 2 movies. So the fraction that represents this would be 3/2. And just so you know, sometimes in this example you're going to write it as a fraction, but lots of times with part-to-part ratios we use a colon, or sometimes we use the language 3/2. Okay. The next type is a rate. And a rate is also a type of ratio, but it compares 2 different units of measure. So one example would be miles per hour, that is your rate of speed. Maybe dollars per year, that would be your rate of pay. So what you're really looking for, lots of times we use the word per, okay, to describe a rate, not always, but most of the time, and that you're measuring 2 different types of things. So in the last one, it was a ratio because we were comparing movies to movies. They each had different attributes, whether they were liked or not liked, but they were both movies. Here we would be comparing distance and time, or money and time. So here's an example. Aaron's part-time job paid him $80 for 10 hours of work. How many dollars was he paid per hour? So to represent this as a fraction, since it says dollars per hour, we would put the number of dollars over the number of hours. Okay? And again, for now we won't simplify, but you may see that this is $8 per hour. Okay? And the last type is an operator model, and that's when we're using a fraction to convert one quantity into another type of quantity. like in a conversion. So it takes a fractional amount of one quantity in exchange for another, such as an exchange or conversion rate for different types of currency. So here's an example. The currency here is apples and cupcakes. Sarah gives her friend 3 apples for every 2 cupcakes her friend gives her. What fraction would you use to convert apples to cupcakes? So, notice the words for every. A lot of times for operators, we use for every. Sometimes we use that for regular old rates as well that aren't operators. But the idea is 3 apples for 2 cupcakes, and we want to convert apples to cupcakes. So let's just look at an example. Say you had 12 apples. How many cupcakes would that be? Well, every group of 3 apples, so you divide by 3 apples. So that would give you 4 groups of 3 apples. And then for every group of 3 apples, you'd get 2 cupcakes. So you'd multiply each of those by 2 cupcakes to get 8 cupcakes. Okay. Now notice that's not what it asks us to find. It just asks us to find the fraction you would use to convert apples to cupcakes. I'm just using this example to show you the process so we can develop the fraction. So to convert from apples to cupcakes, you need to think of the fraction as dividing by the number of apples that you need. Okay, so here we started by dividing by the apples, and dividing goes in the denominator, just like we did when we had division up here. And then you're going to multiply for the number of cupcakes you get, which we put in the numerator. Okay, so 2 cupcakes for 3 apples. Okay, and if you wanted to convert from cupcakes to apples in the reverse direction, you would reverse this conversion rate and the apples would go on top, the cupcakes on the bottom.